Welcome to Module 2.4, Perpetuity. So this lesson has two learning objectives. What is a perpetuity and how do I calculate the value of a perpetuity? So far in this module, we have been working with two generic examples, and each with a finite number of years. For instance, in the example with Coca-Cola and Facebook, we only included the cash inflows for 5 years. In reality, when you buy a stock, you acquire the right to the cash flows as long as you hold the stock. Now, you might be thinking that it will be an almost impossible task. A company might operate for at least a century, so you might wonder if and how you need to forecast and discount for the next 100 years. And even so, how does that even work if you are an investor at age 20 or age 60? Does the value of the stock change then? Well, luckily there is a mathematical solution to that, and it's called a perpetuity. It's an approach to give an infinite series of cash flows a finite present value, and it's possible because of the time value of money, and as we saw in Module 2.1, each payment is only a fraction of the last. Let me give you an example that illustrates that by using this formula. Free cash flow divided by the discount rate. So if you expect that Microsoft will be spending off $3 in free cash flow every year indefinitely, and you estimate the discount rate to be 10%, the intrinsic value of one Microsoft stock is 3 divided by 10% equal 30, or it has a value of $30. We just calculated a zero growth perpetuity, and it's an approach that gives you a quick idea of the stock valuation without doing a thorough analysis and thereby perhaps quickly move on to another security. So if a stock has been generating a somewhat consistent free cash flow for some time, obviously it's not the same as concluding that it will continue to do so. One can both argue for growth and a decline, but again, this is to give you a quick overview. I would take a conservative estimate of the free cash flow, which is the numerator, and I'll divide it by a conservative discount rate. If you play around with the numbers, for instance, if you want to be on the safe side and use a discount rate of 12% for Microsoft, you end up with an intrinsic value of 3 divided by 12%, or $25 for one share of Microsoft. It's a very neat formula, and once you start using it, you'll quickly find how many stocks you can filter away just because of the valuation. The second step is to include growth in our perpetuity model. I'm a very conservative investor, and while growth gets me excited about stocks, it's not something I want to rely heavily on. Growth by definition requires something to happen. So in our example, you might be hoping that Microsoft will come up with a newer and better operating system to make the company more profitable. I can easily see that happen, but I like the idea that the existing business doesn't have to improve to justify the price I'm paying for the stock. For that reason, I first suggest that you include either none or a very low growth rate, especially if you don't know too much about the company. Our perpetuity formula, when you include growth, looks like this. Free cash flow divided by discount rate minus growth. So in the case with Microsoft, again, you might have a free cash flow of $3, a discount rate of 10%. Now we need to figure out what the growth rate is. Now the growth rate we're using in the formula is the long-term growth rate, which is how we expect the stock to grow indefinitely. For both mathematical and practical reasons, I typically set a long-term growth rate to be around 2 to 3%, which is similar to what the overall economy can expect to grow. You really can't set it much higher, since in theory that would imply that your stock eventually would be worth more than the national output. So let's be conservative and use 2%. You can see that we end up with an intrinsic value of $37.50. If we were to use a 3% growth rate, we would end up with $42.90. As you can see, the math behind stock valuation is very simple. The trick is rather to understand and estimate your inputs fully. Now you understand the different valuation concepts and how to estimate the right discount rate. In Module 3, Preston and I are going to show you how to estimate the cash flows and how the different valuation concepts can be put together in a valuation model.